What if I told you that some of the most stunning natural ice formations on Earth are actually frozen time bombs, holding a secret that could reshape our understanding of climate change? Picture this. You're walking across a perfectly frozen lake in the dead of winter. The ice beneath your feet is so clear it's like looking through glass. And there, suspended in the ice, are thousands of delicate, shimmering bubbles, stacked like pearls, glowing with trapped light. They look magical, almost otherworldly. But what you're actually seeing is something far more complex and volatile. These aren't just air bubbles. They're pockets of methane, a gas that's been brewing at the bottom of the lake, slowly rising, only to be frozen in time. So, how do these beautiful formations come to exist? And why do scientists see them as both a wonder of nature and a warning sign? Let's start at the beginning, on the lake floor, where life, death, and chemistry collide. In lakes around the world, especially in northern regions like Canada and Siberia, organic material, dead plants, algae, and animals, sinks to the muddy bottom. There, in the cold, oxygen-poor environment, bacteria go to work. They break down this organic matter through a process called anaerobic digestion, and one of the key byproducts of that process. Methane is lighter than water, so it wants to rise. In summer, it simply bubbles up to the surface and escapes into the atmosphere. But in winter, something different happens. As the lake begins to freeze, the methane gets trapped. It rises through the water column, but when it hits the ice sheet from below, it can't break through. So it pauses, it gathers. And as more methane rises, these pockets stack up, layer upon layer, frozen in place like suspended breaths. But here's where things get even more fascinating. Not all methane bubbles are the same. Their shape, size, and arrangement tell a story about the conditions that created them. In some lakes, you'll see large, singular bubbles, the result of a sudden release of gas. In others, you'll find delicate chains, like strings of pearls, formed by a slow, steady seep. The clarity of the ice matters too. The cleaner and clearer the ice, the more perfectly preserved the bubbles appear. Murky or snow-covered ice can obscure them, turning what might be a crystalline gallery into a hidden archive. And then there's the color. Methane itself is invisible, but the way light interacts with the ice and the bubbles creates those stunning silver and white spheres. In certain angles, you might even see hints of blue or green, a trick of the light, but one that adds to the mystery. Now, you might be wondering, why does any of this matter? It's not just about the beauty. Methane is a powerful greenhouse gas, more than 25 times more effective at trapping heat in the atmosphere than carbon dioxide over a 100-year period. And these frozen bubbles are essentially storing that methane temporarily. When spring comes and the ice melts, that methane is released into the air. In small amounts, it's just part of the natural cycle. But as the planet warms, scientists are seeing something concerning. More methane being produced in lakes, and more of it escaping. Think of these frozen bubbles as tiny time capsules, each one holding a record of the methane produced in that lake over the winter. When researchers drill into the ice and collect samples, they can analyze the gas inside. They can tell how much methane is there, where it came from, and even how old it is. In some lakes in the Arctic, methane bubble formations are becoming more abundant, a sign that warming temperatures are accelerating the decay of organic matter at the bottom. It's a feedback loop. Warmer climates lead to more methane, which leads to more warming, but it's not all doom and gloom. Understanding these bubbles helps us model climate change more accurately. It also reminds us of the delicate balance in these ecosystems. Some lakes have been bubbling for thousands of years. Others are new players in this cycle, awakened by changing conditions. There's also an element of risk that few people realize. In rare cases, these methane deposits can become hazardous. If a large pocket of methane is trapped under the ice and suddenly released, say from a crack or a pressure chain, it can explode. There are documented cases of ice shattering unexpectedly, not from thinness, but from methane ignition. It's a reminder that nature's beauty often comes with an edge. What's truly remarkable is how these frozen methane bubbles connect the microscopic world of bacteria to global climate patterns. A process that begins in the mud at the bottom of a lake ends up influencing the atmosphere we all share. And when you stand on that ice, looking down at those trapped spheres, you're not just seeing a pretty pattern, you're witnessing a moment in a much larger story. So the next time you see a photo of these icy marvels, remember, they're not just frozen art, they're messages from the deep, records of life, death, and change, suspended in time, waiting for the thaw. Have you ever seen frozen methane bubbles in person, or is there another natural phenomenon you'd like us to explore next? Let us know in the comments. And don't forget to subscribe to Nature Unlocked for more journeys into the hidden wonders of our world.